In Module 2, Section 3, we will discuss one main concept, and that concept is adding real numbers. Adding real numbers can be visualized on a number line. A positive number can be represented on the number line by arrows of an appropriate length pointing to the right, and a negative number will be represented by an arrow of appropriate length pointing to the left. Let's look at an example of that. If we wanted to add -5 and 2, we would start at 0, and we would draw a line, an arrow pointing to the left 5 units, because 5 is negative. If we did that, that would give us a value of -5. We then draw an arrow to the right of length 2 units, because 2 is positive. So starting at 5, we go to the right once, we go to the right twice, we would end at -3. So the answer to the solution would be -5 plus 2 equals -3. This is a perfectly fine way to think about adding real numbers when we have negatives and positives. But for every example, it would take a very long time to draw a number line. So instead of drawing a number line for each example, let's look at the rules that govern the process of adding two real numbers. If we have two real numbers with the same sign, this means they are both positive or they are both negative. We will add their absolute values. Once we add the absolute values, we will use the common sign as the sign of the answer. Let's say the two real numbers had different signs. One number is positive, one number is negative. In this case, we would subtract their absolute values. We would then give the answer the same sign as the number with the larger absolute value. Let's look at a few examples. For example A, we have -8 plus -3. Now we can see in this example that both numbers are negative. So we're going to follow the first process that was outlined on the previous slide. Because both numbers are negative, we will add their absolute values. Remember, absolute values are always positive. 8 plus 3 is 11. But once we add the absolute values, we assign the same sign that both of the original numbers had. Remember, both original numbers were negative, so our answer should also be negative. Therefore, -8 plus -3 is -11. For part B, we have -7 plus 1. We have one negative value and one positive value. So we're going to follow the second approach outlined on the previous slide. Because our numbers are different, we are going to subtract the absolute values of each number. The largest absolute value minus the smallest absolute value. So the largest absolute value in the statement would be a +7, because remember, all absolute values are positive. The smallest absolute value would be 1. 7 minus 1 is 6. Once we find the difference of the absolute values, we assign the answer the same sign as the larger magnitude from the original two numbers. We had a -7 and a +1. -7 is further away from 0. Its absolute value is larger than +1. So our answer will be a negative number. We'll carry the sign of the larger value, or the larger absolute value. So the 6 will actually be a -6. -7 plus 1 is -6. In part C, we see we also have a positive value and a negative value. +9/10 plus -2/10. So we start by subtracting the absolute values. 9/10 is larger than 2/10, so we have 9/10 minus 2/10, which is 7/10. And in this example, the larger absolute value was that of the positive number. So the answer should be positive. 9/10 plus -2/10 is a +7/10. In the last example, we have -12.6 plus -1.7. Because each of these numbers have the same sign, we're going to add the absolute values. So we add 12.6 plus 1.7, and that will give us 14.3. But remember, when we are adding two numbers, we always keep the sign of the original numbers if they had the same sign. Here, both of our original numbers had a negative sign, so our answer should have a negative sign. So negative 12.6 plus negative 1.7 is negative 14.3. When we speak about positive numbers and negative numbers, it's helpful to talk about additive inverses or opposites. An opposite or an additive inverse, these are two numbers that are the same distance from zero on the number line, but lie on opposite sides of zero. So 8 and negative 8, for example. 8 is 8 units to the right of zero. Negative 8 is 8 units to the left of zero. These are called opposites. The same is true with negative 2.9 and positive 2.9. Here we see that the opposite of a negative number can be represented by two negative signs. We can think of the negative number in this example as meaning the opposite or opposite of. So let's try to find the opposite of each number listed on this slide. We have negative 16, and using the same terminology from the last slide, the opposite of negative 16 is positive 16. For part B, the opposite of 5 is negative 5. 5 is 5 units to the right of 0. Negative 5 is 5 units to the left of 0. Now parts C and D will trip up many people as they go through the homework. Before we find the opposite of an absolute value, let's first evaluate the absolute value. Remember, the absolute value of negative 4 is positive 4. The opposite of positive 4 is negative 4. So the opposite of the absolute value of negative 4 is a negative 4. The absolute value from the beginning is a positive value. The opposite of a positive value is always a negative value. Let's work D the same way. The absolute value of negative 2.9 is a positive 2.9. But because we have a negative sign on the outside, the answer will actually be a negative 2.9. And we have not found the opposite yet. We've only evaluated the original expression. The opposite of negative 2.9 is a positive 2.9. And these are the final answers for each of these four examples. In general, if A is a number, then the opposite, that's what the first negative sign represents, of negative A is positive A. The nice thing about opposites is if we add two numbers that are opposites, the sum, that's the word we use to represent an addition problem, the sum is always 0. So let's use our knowledge of opposites to simplify each of these expressions. On part A, we would read this expression as the opposite of negative 16. And the opposite of negative 16 is positive 16. Another way to think about it, if we have two negatives side by side on a number, they become positive. On part B, the opposite of negative 5x would be a positive 5x. We change the value of the sign when we find opposites. Part C, and remember here we have absolute values, so we should be very careful when dealing with the opposites. We want the opposite of the absolute value of 9. This is the same as the opposite of positive 9 or negative 9. And part D, we want the opposite of the absolute value of negative 2. The absolute value of negative 2 is positive 2. The opposite of positive 2 will be negative 2. So make sure you always evaluate the absolute values first and then assign the opposite value. Now that we know how to add and subtract, or at least add with positive and negative numbers, let's evaluate an expression. So we want to evaluate 5x plus y when x equals 4 and y equals -2. Remember, the first step is to substitute the values in place of the variables. So 5x plus y equals 5. In place of x, we put 4, and I always put my numbers in parentheses when I substitute them into the variable expression, plus -2. -2 takes the place of y. And as you can see, we also put -2 in parentheses so that we don't lose anything. So we use our order of operations. Hopefully you remember this from the previous section. We don't have parentheses, so to speak. At least we don't have operations inside of parentheses. We don't have exponents. We do have multiplication. 5 and 4 are being multiplied. 5 times 4 is 20. So we're left with 20 plus -2. Because we are adding two values that do not have the same sign, have one positive value, one negative value, we start by subtracting their absolute values. The absolute value of 20 is 20. The absolute value of -2 is 2. 20 minus 2 is 18. So we take 18 and we want to assign the value of the larger number, the larger absolute value. 20 had the larger absolute value, and it was positive. So 18 will also be positive. We're finished. The expression, once evaluated with 4 and -2 for x and y, equals 18. Let's try a word problem to end the section. The lowest temperature ever recorded in Sundance was -28 degrees Fahrenheit. The highest recorded temperature in Sundance was 143 degrees higher than the record low temperature. Find Sundance's highest recorded temperature. So let's try to think of this from a number line perspective. And then we'll actually write an expression that represents this word problem. So let's say we have a horizontal thermometer, and the lowest temperature, which would be to the left of 0, is -28. We are then told that the highest recorded temperature was 143 degrees higher. That would be a positive number. So from -28, we would draw an arrow to the right that represented 143. We want to find where that would end. What point on the number line would that be? And the way we do that is by adding these two values. -28 plus 143. Just like in previous examples, when we have two values that have opposite signs, 28 is negative, 143 is positive, we start by subtracting the absolute values. The largest absolute value is 143. The smallest absolute value is 28. So we start by subtracting 143 and 28. 143 minus 28 is 115. Now before we can agree that 115 is the answer, we have to make sure we have assigned the correct sign to 115. When we go back to the original problem, 143 had the largest absolute value, and 143 was positive. So because the largest absolute value was positive, 115 will also be positive. So the answer here is 115 degrees Fahrenheit, a positive value. Make sure to work hard on the homework for Module 2, Section 3, and ask your instructor questions when you have them.